In the previous lesson, we used a polynomial in expanded form to identify the end behavior of a graph. In this lesson, we're going to focus on factored polynomials and what that tells us about the middle of the graph. So first, a couple of definitions, and that's a connection between a number being a zero and a corresponding factor. If the number a is a zero of a polynomial, then x minus a is a factor. The connection is, if you take this number and put it in place of x, you get a minus a, which is 0, which is why we call a 0. It makes the equation equal 0. Furthermore, if you were to factor a polynomial and you end up with x minus a, it could be to an exponent of 2, 3, 4, or 5, and in this case, we say that the factor is of multiplicity k, depending on what the exponent is. So if we take a polynomial and completely factor it, we say that the polynomial is in factored form. So in example 1, let's just go over these definitions from this equation here. And we're going to go in a couple of steps. I want to identify the factors, the multiplicities, the zeros, and then talk about what the degree of this polynomial has to be. So first things first, this is definitely not an expanded form. This is clearly in factored form. We have 3 different pieces being multiplied together. So if we were to list out what the factors are, we have x minus 6, we have x plus 4, and the x by itself you could really write as x minus 0 if you'd like. You can leave it just as x, there's nothing wrong with that. But these technically are the 3 factors of the polynomial. Now the corresponding multiplicities would be 4, 3, and 1. We don't write the 1, but it's definitely implied. So these are the 3 factors, and these are the corresponding multiplicities. So all the multiplicity says is you have x minus 6, but it's being multiplied in 4 times. Here you have x plus 4, but it's being multiplied in 3 times. Here you have x, but it only appears once. Okay, so once you know what the factors are, you can determine the zeros. So from the factors, what are the zeros? And this is very easy to figure out. All you have to do is think about what number makes the factor equal 0. And clearly in this one is going to be 6. So 6 is the 0. And the reason for that is if you put 6 in place of x, you get 6 minus 6, which creates a 0. If you raise that to the 4th power, it's still 0. Moving on, if you have x plus 4 as a factor, it has to be that negative 4 is a 0. That thing makes this factor equal 0. So we get negative 4. And for the last one, we have x minus 0, or simply x. Clearly, if you put 0 in place of x, it makes the equation equal 0. So the number 0 itself is a 0. So what these 3 numbers do is if you put them into this equation, it makes the equation equal 0. So we have the factors, the multiplicities, and the zeros. The last thing is, what is the degree of this polynomial? So I'm going to write down the equation again. What's the degree? So the equation is y is equal to x times x minus 6 to the 4th times x plus 4 cubed. And here I wrote this fact. If all of your factors are linear, and they are x plus 4, x minus 6, and x, the degree of this polynomial is going to be equal to the sum of the multiplicities. So what I'm going to do is put a 1 here, and note that the multiplicity here is 1, the multiplicity here is 4, and the multiplicity here is 3. That means the degree of this polynomial is 1 plus 4 plus 3, or simply 8. If you think about why this fact is true, if you start over here and multiply this out, if you cube this thing, it would give you an x cubed. You'd have a lot of other stuff, but you would definitely get an x cubed when multiplying this thing out. If you look at this next term, x minus 6, and you raise it to the 4th power, you're going to get a bunch of stuff, but the biggest thing that you have is going to be an x to the 4th. Here there's nothing to multiply out, it just would give you this x. And if you were to multiply these things together, you'd have to multiply an x times an x to the 4th times an x cubed, and the rule we have is that we add those exponents. This would be the largest number as an exponent that appears within your equation. So that's the justification for this rule, but if you believe that it's true, you can simply add these exponents to figure out the degree. Now that we have all these definitions in mind, what I'd like to do is graph this function y is equal to x squared times x plus 5. I'm going to do this by using the degree, the zeros, and the multiplicity. And you can even start by putting this thing into your graphing calculator to check your work, but I'm just going to list a few things off to the side. First of all, for this polynomial, what's the degree? What are the zeros? And their corresponding multiplicities, which I'll put this. So if we start with the degree of this polynomial, the degree is going to be equal to 3. And that's simply coming from the sum of the 1 and 2. That tells you a lot about the graph. Because the degree is odd, it means it has to go up on one side and down on the other. I mean, clearly the leading coefficient is going to be a positive number, so I know the graph would have to go up on this side and down on this side. We'll keep that in mind. Second thing is, what are the zeros of this polynomial? There are only 2 because there's 2 factors. Here we have x squared, and here we have x plus 5 to the first. The 2 zeros are going to be -5 and 0. And all I did to figure that out was think about, well, what number do I put here to make 0? Clearly it's -5. What number do I put here to create 0? 0. Now if I want their corresponding multiplicities, the multiplicity at -5 is going to be a 1, and the multiplicity at 0 is going to be a 2. And that's going to tell us something about the graph as well. Let's take all this information and graph this function. So I do not have the y or x-axis scaled. What I'm going to do is place numbers on the x-axis and just get a rough sketch of what this graph looks like. Let's start by plotting 2 points that we know for sure, -5 and 0. So let's plot those. I know this point's on the graph because I said 0 is a 0, and so is this point right there, -5. Okay, the other thing that we know about the degree is whatever my graph is, it has to go between those 2 points, but it's going to go down on this side and then up on this side. So I'm going to put that in here as a reference. Whatever the graph is, it's got to be up on this side and down on this side, and that's because the degree is odd. All right, the rest is just now connecting this side of the graph to this side of the graph by passing through or around those 2 zeros. So the first things first, we go up to this point here, and this point is determined from this factor. Because the multiplicity is equal to 1, we're going to pass through that point. So it would look like this. The graph goes up to this point, and because the multiplicity is an odd number, it goes directly through that 0. So it goes up some amount, but it has to come back down and go to the second 0. Now the multiplicity here comes from this factor, and it is of even multiplicity. That means it's going to look like the graph of x squared, meaning it stays on the same side. So I go down to this point, it looks like the graph of x squared and connects up here. So here's the process to getting a graph of a polynomial. Identify the degree, the zeros, and their multiplicities. Plot the zeros, write down what the degree tells you about the ends of the graph, and then connect one side of the graph to the other by using the multiplicities. So let's do that again in the graph of x times x plus 5 squared. So this is really similar to the previous example, but let's just go through it a little bit more quickly. So we have the degree, the zeros, and their corresponding multiplicities. The degree is still 3 because we have x to the first, x plus 5 squared, and we get that 3 is the degree. The zeros are also the same, -5 and 0. Those did not change, but the multiplicities did change. The multiplicity for -5 is a 2, and the one at 0 is now a 1. And that's going to affect what happens at those 2 points. Let's sketch this all in. Here we have -5, and 0 are my 2 zeros. The degree is odd, so whatever this graph does, it has to go up on this side and down on this side, so I'll plot that next. And now all I need to do is connect this end of the graph to this end of the graph by using the multiplicities. The first thing that happens is this graph has to go up to this point. This was determined by the factor x plus 5 squared. Because the exponent is a 2, it stays on the same side of the graph. just like a squared function would. It goes up to this point, and then it comes back down. Now, it eventually has to go back to this point here, so we're going to follow along. And when we get to this point, this is coming from this x to the first power. Because the multiplicity is 1, it's going to pass through that point. And this is the sketch of my graph. All right, one last example here. Again, really similar, but I changed the exponents on both x and x plus 5. So I'm going to start by writing down the degree. This time the degree is 3 plus 3, or 6. The zeros, that did not change yet again. We still have -5 and 0 are the zeros, but the corresponding multiplicities are different. Here, for -5, the multiplicity is 3. And here for 0, the multiplicity is 3 as well. That will mean at these two zeros, it's going to pass through the graph on the x-axis. So I'm going to start by plotting -5 and 0. The degree is even this time. That means the graph, whatever it does, it has to go up on both sides. So it's going up here and here. In the last two examples, the degree was odd, which meant it was going in opposite directions, but not for this one. All right, the graph has to go down to this point. This one comes from this factor, whose multiplicity is 3. That means it's going to pass through the graph like an x cubed function would. So that means it goes down to this spot. It equals 0 here. Kind of levels off like x cubed, but then drops down again. It goes down some amount, but it has to come back up to this point. And this point is coming from x cubed, which means it's going to pass through the graph there. So it goes down a little bit, it comes back up. It has to look like the graph of x cubed, so it levels off a little bit and then goes back up through this point here. So putting this all together, to understand the graph of a polynomial, we're using the degree to get the ends of the graph. The factored form tells us what the zeros are, so we could plot those 2 points, and the rest is just connecting one end of the graph to the other by using the multiplicities.